I hope that was interesting. I hope you figured it out. I'm going to show you how I would have solved that challenge. And maybe you will see some things I did and say, ooh, I wish I would have done it that way, or I see that's a different way to do it. And if you did it some different way than I show that works, you know, great. But it can be useful to just look at different solutions to problems. I'm going to begin by, I'm just leaving that challenge text intact at the top, but I'm going to actually paste something that's the beginning of a little thing, a pin mapping. This is, as we start to have more and more pins doing jobs in our sketches, it's going to be better to have a sort of a more clear little section at the top of your code to just specify exactly what pin is doing what job, because the bigger it gets, the more complicated your code will look and be, and you'll want to have a point of reference like this. So I'm going to say pin A0 is going to be an input pin, and that will be potentiometer. It sets the blink rate. Pin, let's say 5, will be an output, and that will be an LED. You don't really need much more description for that. I'll make pin 8 a different input as well. Push button, effect, blink rate. Maybe I should have put these in a different order, the 2 inputs than the output, but whatever. I'm, additionally to this, going to do a new trick, and I'm going to refer to this pin mapping when I do it. I'm going to, instead of, let's say, doing analog read of A0 later in my code, blah, blah, blah. Instead of that, I want to put something in A0 that looks more like an actual variable that has a good name rather than doing this. So at the very top of my code, before I write all the rest of the stuff, I'm actually going to define some new variables. I could say int pot pin equals A0. Now that's kind of a funny thing. I've labeled it in all caps. That is intentional. And this is kind of funny. Think for yourself, what is the funny thing happening on line 22? What is weird about this? I'm saying I'm making a new integer. It's called potPin, and the value is A0. But like, wait a second. A0, that's not a number. And an integer can only store a number. Well, in fact, behind the scenes, A0 is a number. Behind the scenes, the Arduino software, when it reads this, it turns A0 into a pin number, which actually, if you look at your Arduino, there's 0 through 13. Actually, A0 means the same thing as pin 14. A1 means the same thing as pin 15, etc. And so the A5 is actually pin 20. That's the 20 pins you could think about as having on the Arduino. So what we're doing here is making a variable so that later we can say something like analog read potPin. This is like way more legible and way less error prone than if we were to have to do A0 every time. The other advantage of doing it this way is that if later I change where it's plugged in, I could just do this up at the top, and then all the rest of these would automatically change later in the code. So from now on, let's do this. And one more little trick when we're doing these. I'm going to call this the pin mapping, pin constants. When we make these, instead of saying just int potPin A2, we're going to say const int potPin equals A2. And what that actually means is this should never change. So whereas in other things we could say, with other variables rather, we could say potPin equals potPin plus 3 or something. If we use this const special sort of tag at the front of the type of variable we're making, it will tell the computer, no, this should never change values. This should always remain at whatever that initial value was, which will protect you from accidentally changing the value later. And the other thing is to use all caps for these. So to actually complete this little, pin mapping section, const int potPin is A0, const int LED pin is 5, and const int, oh my gosh, button pin equals 8. Now let's just jump into the code. Void setup. I'm going to declare the modes of all of my pins. So I will say pin mode pot pin is an input. I will say pin mode LED pin is an output, and pin mode button pin, button pin is also an input. I don't actually need any serial feedback for this. The assignment didn't specify it, so I'll just leave that off. The challenge rather didn't specify it. However, if you were having some confusion, like, whoa, why isn't this thing working? Use the serial debugger. I mean, that's like the great value of that is you can actually check on things and see what the Arduino is thinking. Now in the loop. And I'm actually going to use auto format because I'm seeing that my alignment is a little funny here and I don't really like that. So I'm going to select auto format and fix that. Okay. In the loop, I'm going to check the state of the potentiometer and button. I'll do that by making a new variable called potVal equals analog read pot pin. And buttonVal, that'll be a digital read of button pin. I like to sort of check the state of the world first and then move on. Then I can do things based on observations. For instance, in this case, if buttonVal is high, which means the button is pressed, have the blinking rate. Okay, so we're going to get to that and figure out how we will have the blinking rate. And so when I say things, I'll say calculations based on observations. Do internal things, internal to the Arduino, not external to the world. And now finally, change the outputs. So how will I change the things in the world? Well, I'll just do a digital write of LED pin. I'll turn it on, delay for some amount of time, turn it off, and delay for the same amount of time. I have left the parentheses blank for right now, but they'll need to be filled in. So if the button value is high, that means the button is pressed. If the button is pressed and the blinking rate should be cut in half, then what should the delay, how should that change? The delay should be doubled. So what I'm going to do in here actually is just say potVal equals potVal times 2. This will double potVal. And doubling the delay means half the rate. So then my actual delay things in here can just be potVal, just as they were before. No big surprise. But notice that I don't need to write two different ways of blinking. I don't need to say delay potVal times 2 and put that inside of the if and then have an else that says otherwise just do potVal times 1. Rather, I can just change the value of an internal variable, potVal, and then by the time it hits this point in the loop, either potVal, let's say the potentiometer is turned to the position where it would be 500. By the time it gets to this time in the loop, either potVal is still 500 because buttonVal is not high and it has not been touched, so it's still 500. It'll do its blinking at 500 milliseconds between the blinks. Or if the button was pressed, then 500 times 2 is 1,000. So potVal now contains the number 1,000. And so now this will just be 1,000 and this will be 1,000 until the loop runs again. When it gets back to the top of the loop, it starts over and it reads the pin again. So that is my solution to the challenge. And I hope that's helpful. And maybe you got a few pointers about additional things you might want to do in your code moving forward. Also, I will note that this having a pin constant section at the top of your code is absolutely doing yourself a favor, because writing those numbers in the code, as soon as it gets anything complicated, as soon as there's more than like 3 or 4 things plugged in, the numbers start to be really confusing. So I highly recommend naming all of the constants you're going to be using to store pin values.